Hey everyone, this is my first real video, and yes, I hope you enjoy. So a neutron star is a very extreme version of a star. A very, 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 very extreme version of a star. It's very dense, very extreme, very dense and violent. So basically this is how a neutron star forms. So let's say there's a star about 8 to 20 times the mass of our sun. Basically, it's living its core. If it's that massive, then it can become a neutron star. So basically, this kind of star is living like it's a normal star life, but then, so basically fusing elements: hydrogen, hydrogen, helium, 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 and so on. Like helium is this second element, and second plus second element would fuse for the fourth element and eighth element, which is, and then it would fuse continuously. But then there's a point where the star reaches iron. If it's the sun will not reach iron, but stars like neutrons, the stars that become neutron stars do, because they're really, really hot. And something different about iron fusion than other previous fusions is, instead of creating energy for the star, it steals the energy and it puts it inside the iron. And then, after it's inside the iron, basically the star is losing lots and lots of energy. So basically there's, in the star, it's like a pile of iron at the core, and it's growing, 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 and eventually it becomes exhausted of hydrogen, helium, and all of those other elements, and then and the star cannot sustain itself. So when the star cannot sustain itself, basically, when it's a star, it has two forces: gravity pushing it in, and something pulling out to counteract the gravity trying to push it together. But when it becomes like this, the gravity gets so strong, and the atoms cannot resist it. It is so very, very, very strong, that it actually just pushes it together really, really, really hard, and basically pushes the atoms. And sometimes if the star is very massive, meaning it has a lot of mass, it will actually make the atoms' cores hit each other, because normally, I've never really touched anything in my life. I cannot touch my computer, I cannot touch my desk, because there's a tiny space between all of those. Oh, also, an atom is also 99.99% empty space, which is a lot. If the nucleus is a piece of dust, then the entire atom could be like a giant house. So, with all that in mind, neutron stars, they're really, really powerful. They're stronger than the electrons and neutrons and protons of an atom. They're stronger than the atom itself. And basically the gravity of the star pushes it together, pushes the atoms together, that their cores actually, for the first time, hit. And then it's really, really dense, and yeah, so it creates a material called by many scientists Neutronium. So a really interesting element. It's not an element, sorry, it's a material. And basically the first few centimeters of the neutron star will be, as that's its normal matter, and then below that is like very, 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 very dense iron. If a part of that area breaks, it will create a neutron star quake, which is really, really powerful, and it is really strong. And basically, a neutron star, let's say it's 2 times the mass of a sun, it would be only the size of a small city, maybe like let's say Manhattan. It will be really, really small. That's the point. And it has more mass than the sun. Imagine that. 2 suns fit in a city. It's They're very, very small. They're very, very dense. But it gets even weirder. So, neutron stars, they spin very fast. They have very strong magnetic fields. But there are more types of neutron stars than just one. There's also called pulsars, which, if a neutron star spins really fast, it will start to eject radiation, X-rays, and all, gamma rays, and all those forms of radiation. And it actually, yeah. A neutron star would be able to fly, maybe erase all your data on your cell phone, maybe just more than a few kilometers away. So it's really, really powerful, and basically emits lots of radiation. That's how the first pulsar was, by the way, detected. And basically, scientists thought it was an issue with their device, but it was actually a pulsar which was making the constant noise. Another type of neutron star is called a magnetar. Basically, just like normal neutron stars, but they have such a high magnetic field. Basically, they're just like regular neutron stars, but what happens to them is they start spinning really, really fast and vigorously, as you could say, and basically that creates a much stronger magnetic field than normal. Now, those are much more powerful, but it does come with a consequence, and the consequence is because the magnetic field it creates is so strong that over time the magnetic field will actually pull the neutron star apart, slowing it down even under the intense gravity of the neutron star. And neutron stars are very, very dense and violent, very extreme side of the universe, you could say. They're not as extreme as black holes, but yeah. A few years ago, actually, they discovered a neutron star with planets orbiting around us. Now, usually this is an unusual sighting, but it has happened. So let me get to the explosion. So basically, the star collapses. Right, it can't hold against the really, really strong gravity, and when it collapses, it keeps on collapsing, and then eventually, the neutron star creates a bunch of particles called neutrinos, which get pulled away from the star really, really quickly at half the speed of light. It's what creates a supernova. Because of the very strong gravity, that's what creates the supernova. It's not just it collapsing. And yeah, basically that's it on neutron stars. You could leave in the comment section what other kind of videos you would like to have next. This was my first video, by the way, so I haven't had much experience with making these kind of videos. But anyway, hope you enjoyed, hope you learned. Quick recap. Neutron stars form when 8 to 20 times the mass of our sun core collapses, and it will create a supernova, which releases neutrinos, and it collapses really, really quickly, and it creates Neutronium at the core, which is really dense, and those neutron stars are about the size of a small city. There are many types of neutron stars. Two types are pulsars, which spin really quickly and eject radiation because of that, and magnetars, which have a really strong magnetic field. Anyway, hope you enjoyed. Leave a like and share and subscribe, and I will see you next time. Bye.